Continuing, law of sines has an issue. It's pretty easy to use, but it has this little issue. It's called the Indeterminate Case, SSA. If you remember back to your geometry, we had some congruence theorems. We had ASA, we had AAS, we had SAS, we had SSS, we had HL. Are any of those SSA? No. And that leads us to a problem because we are not guaranteed to have a single triangle if we have the SSA case. You might not have a triangle at all. You might have only one triangle, or maybe you have two different triangles that have the same set of sides and angle but look different. In these examples, we're going to say we know side A, side B, and angle A. If angle A is greater than 90 and side A is less than or equal to side B, you can see side A is not long enough to make a triangle, so there's no triangle. Or, so if angle A is larger than side B, you get one triangle. And you just solve it like we solved the last triangle in part 1. However, if angle A is less than 90 degrees, and the height of the triangle would be b sine of A. Just use this right triangle that you see in the picture. Sine is opposite over hypotenuse, it'd be h over b, so multiply both sides by b. So the height is b sine A. If the height is greater than side A is too short, and there's no triangle. If the height equals A, it is one triangle, and more specifically, it is a right triangle. And you don't have to use law signs at all. You can just use the regular sine, cosine, and tangent and figure it out much more quickly that way. Use Pythagorean theorem, all that stuff. All right, our next one, if A is greater than or equal to B, you get one triangle. But if H is less than A and A is less than B, you get two triangles. It could be this little triangle here on the left, or it could be this big triangle there. Both of them work, but you can see they are very different from each other. All right, let's solve a triangle. ABC, if A is 122, side A is 18, and side B is 12. So again, drawing a triangle is useful. Try to make it somewhat accurate, but you don't have to be perfect. You don't need a protractor and all that. All right, so let's see how many solutions there are. Angle A is greater than 90 degrees, and side A is greater than side B. So if you go back to those 6 different cases that are in your book listed out, that means there is one triangle. So we just solve it like we did the other law signs. I know the A's, and I know one of the B's. So I'm going to go sine of A over A equals sine of B over B. Fill in the numbers for the A's and the B. And then cross multiply. So 18 sine B equals 12 times sine of 122. Sine always goes with the angle. You can't divide by just sine. So we're going to divide both sides by 18. And so sine of B would be 12 sine of 122 degrees divided by 18. Make sure you close the parenthesis on the 122 degrees. That gives you about 0.5654. I want to know the angle. To find the angle, you have to use inverse. So inverse sine of 0.5654 is about 34.4 degrees. The more decimals you keep, the better your answer will be. So on my calculator, instead of just putting 0.5654, I used the previous answer that was stored in my calculator. Now I know two of my angles. I could find angle C. The three angles in a triangle add up to 180 degrees. So I go 180 minus the 34.4 minus the 122 gives me 23.6 degrees. Now I'm going to try to use as much as the original numbers as possible. I rounded to get the 34.4 degrees, which means the 23.6 degrees for angle C is also rounded. So I'm going to use the A's, because I know them exactly from the problem, and the C as few rounding numbers as possible. So sine of A over A equals sine of C over C. Fill in the A's and the C. Cross multiply. C times sine of 122 equals 18 times sine of 23.6. Divide by the sine of 122. Don't forget to close the parentheses. And you get about 8.5. Let's try another one. Okay, angle A is 36 degrees, side A is 9, side B is 12. All right, A is less than 90 degrees, so I need to find H. H was B sine of A, so that'd be 12 sine of 36, which is 7.05. All right, so 7.05 is less than A, and that is less than B, so that means we have two solutions. The first solution, you do nothing special. You just solve it the way you would solve any other triangle using law of sines. So our first solution, nothing fancy. I know the A's, I know one of the B's, so I'm going to go sine of A over A equals sine of B over B. Fill in the numbers for A and the number for B. And cross multiply, so I'll have 9 times sine of B equals 12 times sine of 36. Divide by 9 to get the sine of B by itself. You get sine of B is about 0.7837. To find angle B, I have to use inverse sine. So angle B is inverse sine of 0.7837, which is about 51.6 degrees. Now I know two of the angles. I can find angle C. So I'll go 180 minus the 51.6 minus the 36 gives me 92.4 for angle C. Now using as many original numbers as possible, I'm going to go sine of A over A equals sine of C over C to find C. Fill in the numbers for A and the number for C. Cross multiply. C times sine of 36 equals 9 times sine of 92.4. Divide by sine of 36, and you get about 15.3. And now you have solved the first solution. See, nothing fancy. Second solution. Next slide. All right, our second solution. Let's do some geometry here. I'm going to do geometry to explain it and then just give you a general formula. All right, so think about swinging side A over until it hits side C again. So just follow little white dots and it's over there. All right, since they're both side A, they're congruent, which means the base angles are congruent. So isosceles triangles, so the base angles are congruent. Okay, I want to solve the white triangle there. So I'm going to call the angles that are different, the things that are different, with primes. So it'll be B prime and C prime. So angle B prime is actually supplementary. It's a linear pair with the 51.6. So B prime is going to be 180 minus B. Okay, that's the first formula to help you out. So to get your second solution, you take that angle you found first in the first solution, 180 minus that gives you the same angle in the second solution. So 180 minus 51.6 is 128.4. All right, I now know two of the angles in the white triangle. So I can find C prime. C prime would be 180 minus the 128.4 minus the 36, or 15.6 degrees. And then I can use law of sines to find side C prime. I'm going to use the original numbers, so it'll be A's and C's. It'll be sine of A over A equals sine of C prime over C prime. Find the numbers for A's and C's. Cross multiply. Be C prime times sine of 36 equals 9 times sine of 15.6. Divide by the sine of 36, and C prime is about 4.1. And there we have now solved the second triangle. So the big thing to start solving for the second triangle, you take your angle B, subtract it from 180, and that is angle B for the second solution. And then solve the rest of it as you would normally. One last little bit is finding the area of a triangle. Area of a triangle is 1/2 base times height. If I draw the height in there, and see that little red triangle, I could say sine of A is the opposite, H, over the hypotenuse C. So then if I multiply both sides by C, I'll get H equals C sine of A. So if I fill that into the area formula, the area would be 1/2 BC sine of A. Or you could use any of the angles. It's just whatever the angle is, the other two sides are there. So it'd be 1/2 AB sine C, or 1/2 AC sine B. So find the area of a triangle with A is 10, B is 14, C is 46. So as long as you have an angle and the other two sides, so it'll be 1/2 AB sine C. It's our angle and the other two sides. Fill in the numbers, the 10, the 14, and the 46. Run it through your calculator. Area is 50.4.